All right, guys, welcome back to class this week. We're getting close to the end of the semester, only about maybe 3 weeks left, which is perfect. Yeah, Franz, I got a new mic. So I think I might sound a little better. I hope I do. It's kind of like a headset. It was pretty cheap, but I got it at Fnac. It's like an e-learning headset. Nice. I'm glad I sound better. Yay. Cool. Okay, well, I'm sorry that I had to do that. This happened so late in the semester, but I'm glad that I do sound better. All right. So, oh my gosh, do I ever need a new pen? Well, this is a brand new pen, like top of the line Surface pen, whatever. It's just from what I've heard, it's a common issue with PowerPoint. And somebody at work told me it has to do with the palm recognition. Like it tries to figure out if my hand is touching the screen or the pen. And I've turned it on, I've turned it off, I've done all sorts of things. Anyways, it's a work in progress. So here we go. Let's look at these examples. And I do have a new mic, so if I'm loud or too loud, feel free to turn me down a little bit. Okay, so the way I look at these problems is I break them into two pieces. And I mentioned this to the class this morning, or an hour ago, sorry, that this is a tough thing to teach because there's no formula like C is N over V. There's no one correct method. There's only suggestions I can give you. This is like solving a puzzle. So for me to teach this is like explaining to you how to do a Sudoku puzzle or something like that. There are rules we have to follow, and there's a single solution. There's only one answer, but how you get there is kind of unique to you. So I'll kind of explain how I do this, the method I've been doing for many, many years. I break the reaction in half. I have reactants on the left, products on the right, and I just do a little inventory. I count and see if the elements are the same. And if they're not, I put a number in front of them to make sure that they are. Pretty straightforward. So I immediately notice a big problem here. I have two fluorine atoms on the left, and I only have one on the right. So this is an imbalance, right? We're breaking the law of conservation of mass. So a very quick fix for this would to just be to put a 2 here. Now I have another problem I've just created. By putting a 2 here, I've actually doubled my sodium. I also have two chlorines. So another easy example would be to put a 2 here, and I think I'm done. And to check if you're done, I make a little list. So I say 2Na on the left, 2Na on the right. So that's good. I have two chlorines on the left. Okay, and that's good. And I have two fluorines and two fluorines. Everything is balanced. I have two of every element. Now, one thing I could mention here is some of you might be putting ones here. You can put ones there, but you don't need to. I've said this a million times in this course. It's a lot like math. If there's a 1, you don't actually need it, right? Like if you in math class, if you said 1x equals 3, I'm just up at the top of the screen there. That's the same as x equals 3. They're both fine, but you don't need the 1. So if you basically, if you put a 1 in, you're fine, but you don't need to. There will never be a situation where you'll put a 0. Okay, it has to be a whole number. 1, 2, 3, 4, 5, 6. All right. In the chat, Shadan actually did the answers for the next slide as well. So we'll check those in a minute. All right, let me go a little faster here and get us into the next slide. Okay, so 2 oxygens, 1 oxygen. 2 sodiums, 1 sodium. So I have some problems here. I could balance the sodium right away by putting a 2 here, but a little heads up. This 2 will change. I think I'm going to have a problem with that too, but you could put it there. This is why when you're doing like a lab or something on paper in chemistry, I recommend using a pencil or an erasable pen, because I will see a problem here. Okay, so what about the oxygen? 2 oxygens here, 1 oxygen here. So I'm going to put a 2 in front. Now let's take a step back and kind of count everything. So I have on the reactant side, I have 2 sodiums, 2 oxygens. On the product side, I now have 4 sodiums and 2 oxygen. So by putting a 2 here, I've messed up my sodium, but you know what? That's a really easy fix. Just erase the 2, put in a 4, everybody's happy. So you can kind of see my challenge here teaching this, because I don't have a method. I have a method, but I don't have an answer, like something that will solve every problem. Each chemical reaction is unique, and the way you solve it is unique to you. You might do something different than I do, but at the end of the day, we'll all get the same numbers. Okay, let's look at some harder ones. These are about as hard as they get. They can get actually very challenging. We can, I know some examples of combustion reactions can be crazy difficult. Or maybe difficult's the wrong word, but just a tough puzzle. These are about as hard as you would typically see in chemistry, especially first year chemistry. So Shadan in the chat has the answers, but what I would like to do is just give you guys maybe 1 or 2 minutes to try these. I know I already asked you to try them all, but I want to just, maybe some of you didn't have your notes printed and can't see my slides. So I'd like to just take a break for me for 1 minute, maybe 2 minutes, and I'll come back and we'll do the answers. I think I'm 99% sure Shadan's answers are perfectly correct. So maybe what you guys can do is to check her answers or check for yourself, like see if you get the right answer yourself. So I'll be back in 1, maybe 2 minutes, and we'll look at this together. Answers. Okay, so I'm recording again. Let's check these out. So, okay, let me get something out of the way here. First thing you need to consider with some of these harder balancing problems is this term in mathematics. I'm going to bring a math word in here. Don't get afraid. There's not a lot of math in this, but the term of lowest common multiple. Sometimes it's not as easy as just sticking a 2 or a 3 or a 4 in front of an element and walking away. We need to consider numbers that aren't, multiples of each other directly. Like what I mean is if you look at 2 and 3, I can't just put a 1 in front of 1 or a 2 or something like that. I need to consider how can I get the oxygens balanced. There's a 2, there's a 3. And in math, what the word for that would be, the lowest common multiple of 2 and 3 is, 2 and 3 is 6. The easiest and smallest way to get the numbers 2 and 3 equal to each other is to make them equal 6. So what I would do, I could balance my iron right away, but I think I'm going to have a problem with the iron. So we'll hold off on that. Let's look at my oxygen. If I put a 3 here and a 2 here, now on my product side, I have 6 oxygens. On my reactant side, I have 6 oxygens. So that's all good. By putting the 2 in front of that compound, I have messed the iron up, meaning I need to fix the 2 that I put here. I need to fix it. So I have 4 irons on this side. So I'll put 4 irons on this side. And there we go. That's it. All right, and that one wasn't too bad actually, but the next one is probably the most challenging, you guys would see. So let me pick a different color here. Split the reaction in half. Let's look at this. Actually, the next slide has a pretty cool problem, a balancing problem. But yeah, anyways. So chlorine, I have 3 and I have 2. So kind of the same thing, right? If I put a 2 here and a 3 here, my chlorines will be balanced, right? I have 6 on each side. Now, these numbers I need to consider. Now I have 2 aluminums on this side, and I only have 1 aluminum over here. So I'll put a 2 aluminum on the products. Oops, sorry. Okay, and now my barium, I'll put a 3 in front of my barium. So I have 3 bariums. Okay, I have 6 chlorines and I have 2 aluminums. This stuff on the bottom, guys, you do not ever need to write. Most of your things have been online. If your final exam, or for example, maybe you'll have a lab on campus, like lab number 10, you can do this on a piece of scrap paper if you want, but you don't need to show me your workings. All right, so here's the plan. I want to do one more, and then we'll get into the next section. The next section is the cutoff for your last test. You guys have your last final test, not final exam, but final test on Thursday. You can take the whole day to do that. So from 7 a.m. till midnight, you can do that test. And the next section, not this, but this section is the cutoff. So we're going to do that today and finish it tomorrow, which means on Wednesday we can do some review. I can give you some hints and practice problems. And then Thursday, there's no class. You can do the test on Thursday. So just give me maybe 10, 15 minutes maximum, and we'll kind of do this problem and then introduce chemical reactions. Chemical reactions is pretty straightforward. Okay, balancing. This is a really good problem because this is a review of chapters 3, 4, and 5. I really like this problem. You have to know naming from chapter 3, phases from chapter 4, solid, liquid, gas, and then balancing from chapter 5. Before I do this one, in the chat there, Shadan asked about the final exam. As of now, the final exam, we have been told they have to be on campus in person. I personally don't think that that's going to happen for chemistry 1120 because there's so many of you students. There's not like one of my courses, there's only 14 students. For you guys, we have like over 150, something crazy. Well, maybe 120 at least. So all I can say about your final exam, like for certain, is that it's supposed to be online or on campus, but I'm having a meeting on Tuesday with my boss, me and all the science instructors, physics, chemistry, biology, and we're going to talk about your final exam on Tuesday and see what the government wants us to do and what the president of the college wants us to do. So I don't have a good answer for you, Shadan, and for everybody curious about the final, I do not know for sure. As of now, it's on campus, but I have a weird feeling in my chest that it might be moved online for safety because, again, there are like 120 or more chemistry students. Like there's so many of you. Okay, so we'll talk about the final another time, and we'll certainly talk about your test a little more on Wednesday. But yeah, Humna, your final exam would be on the whole course. It's not as hard as it sounds, don't worry. So, and again, we'll talk about the final in a couple weeks when we get closer to it. It's I've been here long enough. It's not it's not difficult. Okay, So let's look at this example. Like I said, I love this example because it's a cumulative review of 3 chapters: naming, states of matter, and balancing, 3, 4, and 5. So first things first, I need to write the chemical reaction. One thing you need to consider, and this is from chapter 4, or maybe chapter 3. This is from chapter 3, sorry. Elements, particularly non-metals on the periodic table, some of those elements get together to form what's called molecular elements. Now, if this was a question on your test, it's online, meaning you can look this up. You don't have to memorize this for your test. But the molecular elements include hydrogen. Let me go. I guess I'll go in order: nitrogen, oxygen, fluorine, chlorine, bromine. I don't have room there, but iodine would be another one. There are 7 elements, 7 nonmetals that when you find them in nature, they exist as what we would call diatomic molecules, 2 atoms. The other 2 that we learned in chapter 3 are phosphorus, would be 4, and sulfur would be 8. Actually, we looked at this in chapter 2 as well. In chapter 2, we looked at phosphorus and sulfur. And if you can remember, the sulfur molecule is the one that looks like the crown, the thing you'd put on your head. So step number 1 is to remember this from chapters 2 and 3. All right, so let's write this down. Phosphorus is P4. Chlorine is Cl2. And the product here, I give you all of the information. I would have to give you this on a test. That was supposed to say given. Okay. Diphosphorus, so P2, pentachloride, Cl5, and it's solid. All right. Now, let's write the phases. Before we worry about balancing, let's write the phases of these elements. This is easy. So what I'm going to do is I'm going to share my periodic table. I noticed that there's some comments in the chat. I'll read them in 1 second. When you're dealing with elements from the periodic table, you look at the colors, and the colors will tell you the phase: solid, liquid, gas. Remember, synthetic is not a phase. It's just means that it's made in a lab. Okay, so phosphorus, P, this means it's a solid. And chlorine, this means that it's a gas. How do I know this? Because chlorine is in a pink, or whatever color this is, orange, salmon, I don't know. Depends on what it looks like on your screen. But chlorine is in a kind of red, orange, pink kind of square, and phosphorus is in a white square, and white means solid. All right, so let me go back to my notes. I'll put my phases in. Phosphorus is solid, chlorine is a gas. And now I can do the balancing part. So we've just did review from chapter 3. We did naming and formulas. We just reviewed chapter 4. We did phases or states of matter. And now I'm going to get into chapter 5 to balance the equation. And no problem about being disconnected, Sophia. And for Mohammed, the question, if you guys are not in your chat, Mohammed asked a question. How do you know that it's P4? You have to look at your notes from chapter 3. For your test, you do not have to memorize this, because obviously you can use your notes. For the final, if the final is on campus, you'll have to kind of memorize this, but hopefully you'll be online for your final, so you could use your notes. All right, good. That was a good question, because chapter 3 was a month ago, so how you guys might kind of forget that. Okay, so the balancing part now. Sophia has fixed her answer, so your second answer is right. So let's check it out. I'll pick a different color. I'm really feeling orange. I'm really liking the orange color today. So 5 chlorines and 2 chlorines, 2 phosphoruses and 4 phosphoruses. You could balance the phosphorus first, but I know that the chlorine is going to create a little problem here. Not a big problem, but the chlorine, it's going to create a change in the phosphorus. So personally, I'm going to leave phosphorus for the end. You don't need to do that, but if you balance phosphorus first, it won't be correct in your final answer. You'll have to fix it. So chlorine, I have 2 chlorines on the left, the reactants, and I have 5 chlorines on the right, the products. Now, I need a number that 2 and 5 will both go into. So like think of 2, 4, 6, 8, 10, right? Think of 5, 10, 15. I notice that if I can get the chlorines to be 10, I will have my chlorines balanced. The lowest common multiple for 2 and 5 is 10. This is honestly about as hard as they get. Now, because I've multiplied the second molecule in the products, the phosphorus, to 2, or I put a 2 in front of it, that means I will have 4 total, and this is already balanced. It balanced itself. Perfect. A lot of times you'll notice that the chemicals actually do balance themselves. Meaning like this will always work out. It's kind of amazing how chemistry kind of works sometimes. The periodic table is so cool, and some of these molecules will kind of sort themselves out if you balance them correctly. So there you go. That's the answer. And obviously you do not need a 1. Okay, you do not need to put a 1 there. All right, let me check the chat. Yep, so Sophia got the right answer. Shadan gave me the LCM, the lowest common multiple being 10. That is beautiful. Thank you, guys. So it's 3:05. If you guys just give me a couple minutes to introduce the next section, I will, sorry, I'm just reading the chat. I'll give me a couple minutes to introduce the next section so we can get it finished before your test. Abdul Halim asked in the question or in the chat, how do you know the product is P2Cl5 and not P2 plus Cl5? It's because I gave you the name. Remember chapter 3, right? Diphosphorus pentachloride is the name for a molecule. Okay, oops, that word is molecule. So it's not P2Cl5, like, sorry, it's not P2 plus Cl5. That's not how we named molecules in chapter 3. So this is, again, review from chapter 3. Diphosphorus pentachloride is 1 molecule. It's not 2 compounds split together. It's one thing, P2Cl5. I would have to tell you, by the way, that this was solid. You wouldn't have to know that. We don't have any information in our data book. No problem, no problem. All right, the finale of today. And this will get us ready again for your test, which we'll do a review on Wednesday. Tomorrow, we're going to have to finish some of this, but Wednesday, we'll do a review. Okay, so very quickly, give me a couple more minutes. In this section, you can see the outcomes or the objectives here. But in this section, we're going to look at types of chemical reactions. Now, these are not the only types of chemical reactions, but these are one way of classifying them based on what the atoms are doing. So there's 5 of them here. We have decomposition, which I'll do today, or I'll at least introduce today. We have combustion, double replacement, combination, and single replacement. Combination, if you've done chemistry before, or if you're Googling or watching YouTube videos or reading a book, a textbook, some people in different places call it synthesis. I kind of go back and forth. You might hear me say combination, you might hear me say synthesis, but we'll get into that tomorrow. What I'll do today is decomposition. So let's look at this one. Decomposition reactions are exactly what they sound like. Now, this is a horrible definition because we haven't talked about combination yet. But think about the word decompose. When something decomposes, it breaks down. So like food going rotten is what they would call decomposition. Well, in chemistry, it it's similar. It's not that it's going bad or going rotten like food, but it is the same idea that a chemical is going to break down into individual parts. So typically for a decomposition reaction, you have one big reactant. Typically it's an ionic compound. So usually ionic. For this course, not in real life, but for chemistry 1120, it's usually ionic. And there's always only one reactant. That's how you can tell if it's a decomposition reaction. It's the only type of reaction that has one reactant. And what happens typically using heat, we decompose or break the chemicals down into their individual products. It's not always heat. It can happen spontaneously, meaning naturally, but it typically is related to heat. And the hint here is, find the easiest way to split it into two parts. And what that means for chemistry or in chemistry is typically we split it into the cation and anion parts. So there are three types of decompositions we're going to look at. I'll be done in 5 minutes, guys, and then I'll save some practice problems for you tomorrow. But I just want to introduce the three types of decomposition. One, the chemical, the compound can just decompose into its natural elements. Hydrates are the easiest. Hydrates, they decompose but differently. I'll explain that on the next slide or the slide after that. The decomposition of hydrates is like the equivalent of putting clothes in a dryer, drying wet clothes. So when you decompose a hydrate, you typically take a wet water surrounded compound and you dry it out. And I'll explain. And then this one is the hard one, which you probably won't see on a test or anything, but carbonates have a special way to decompose. I'm not putting a star there because it's important. It's just a little more challenging than the first two. Okay, now guys, you'll notice the answer here in red, the 2 is in the wrong place. It just kind of shifted when I made my slides, so we'll do this one together. So when the reactant is binary, meaning there's only two elements, binary meaning two. Bi like a bicycle, right? Two wheels. Binary means two things. So when the reactant is just two simple elements bonded together, the products will be both elements alone. Now, that means we're going to get aluminum, which is a metal. It's a solid on your periodic table, and Cl2. Remember what I showed you a couple slides ago. Some of the molecules, when they're by themselves, exist as, two. So H2, N2, O2, F2, Cl2, Br2, I2. These are common elements that exist as what we would call diatomic. From your periodic table, I know that chlorine is a gas because it's in the pink square or orange square. I don't know why that color is, but it's in that orange colored square. The only thing left to do is to balance this. So I would put a 2 here and a 3 here to balance my chlorines. That means I have 6. And then I would put a 2 here to balance my aluminum. I went a little quick through the balancing part because we just did it, but make sure you know how to balance this. So again, I used 2 and 3 to get chlorine to be 6, and then I added the 2 for the aluminum. All right, what about and honestly, guys, decomposition is one of the harder chemical reactions to predict. Something like synthesis or combustion is very easy to do. All right, let's look at two more very quickly. We will, of course, review this tomorrow and look at the answers. I have a couple practice problems that we'll do. We'll do those tomorrow. All right, two more slides. Okay, what about, excuse me, what about hydrates? A hydrate is literally a wet compound. Some compounds, when you leave them open, maybe the bottle isn't sealed very well, or a student, wink, wink, or hint, hint, leaves the top off the bottle. That drives me crazy in the lab when you guys leave the tops off the bottles. Anyways, what can happen is these compounds can absorb water from the atmosphere. They get wet. Damp might be the right word. So they're not like wet, like dripping water, like after going for a swim. I don't mean that. I just mean that they absorb moisture. This can be good. Some chemicals absorb moisture to keep food safe, to keep clothing from going moldy or smelling weird. I don't know, sometimes when you guys buy these products, there might be like a weird little packet in the pocket of a clothing, of like a dress or pants, or some food items might have something. These are chemicals that absorb moisture, so they keep things from going moldy. And yeah, Iman said it beautifully. I mean, hydrate is the easiest one. The reaction, literally what you do is see how on the, see how on the left I have like a dot there? This is how we write hydrates. This means that I have 5 water molecules for every 1 copper 2 sulfate. The plus just gets put here. I don't have to worry about balancing. I don't have to even worry about phases or anything like that, because what's happening is this is done over heat. Literally like you guys drying your clothes. You wash your clothes, you clean a pair of socks. I don't know if you guys wear socks as much as me. I always wear socks. And your clothes, when you put them in the washing machine, they get wet. It doesn't change their chemical formula. They're just wet. So you hang them to dry, or you put them in a dryer, and the heat in the dryer makes the water evaporate. So the water leaves, sorry, my pen, the water leaves as a gas. And that's why we get a solid and a gas. We're not changing anything. This is still a solid compound, but the water evaporates. That's a pretty easy decomposition reaction. And again, we're going to practice this on Tuesday. The last one is by far the most complicated. So you guys might be tempted to do this. You see an ionic compound. You might be tempted to say, oh, well, we get sodium and CO3. But CO3 isn't a stable compound. CO is stable. CO2 is stable, right? You guys have heard of those chemicals. Carbon monoxide, carbon dioxide. You're breathing out and in some carbon dioxide right now, right? I know some of my biology students might be saying, wait, we breathe in oxygen, we breathe out carbon dioxide. But every breath you take is a mixture of gases in the atmosphere. So nitrogen, oxygen, carbon dioxide. And carbon dioxide is a product from CO3. This is unstable. So what happens is it breaks apart. It breaks apart into an oxygen and CO2 gas. The oxygen would then bond to the sodium. But remember, the oxygen can't disappear, right? That atom has to be there. So my answer for this, and again, guys, this is challenging. This is not the easiest example, would be Na2O. I'll explain where that comes from in a minute, and CO2 gas. Now, where did this come from? Well, remember, the CO3 decomposes into oxygen and CO2, just oxygen. And the oxygen would bond with the sodium metal that was there. and we would get Na2O. Now, why 2? Well, remember, the charge on sodium, this is back from chapter 3, the charge on sodium is 1 plus, the charge on oxygen is 2 minus. So, I do that crisscross method, and I would get Na2O. This one, very challenging, and I don't think personally I would put this on a test or a final exam, but it is good to know. So there you go, there's your answer. And you'll notice it's already balanced. I don't have to worry about balancing. All right, I'm done. Let me just check the chat. Yeah, so Aman brings up, a good little hint there. It's easy if you write it as CO2, and then what's left will be the second product. That's a really good way to think about it. So like, I'm pretty much done, but let me kind of elaborate on that because that's a really good point. Take this molecule, remove CO2, and ask yourself what's left, right? And that's a beautiful way to think about that. Na2CO3, the CO3 is very unstable, so the CO2 leaves, and what we're left is Na2O. That's a really good way to think about that. The only challenge here is you have to remember this, or I guess for a test, you could use your notes, but remember that this only happens for CO3. Okay, there's no other examples in this course like that. There are, of course, examples that decompose, but for chemistry 1120, we keep it simple. And ironically, speaking of keeping it simple, decomposition is probably one of the hardest ones. The simple or single replacement or combustion. My brain is not working today. They're very easy. Anyways, I'm done for today. So tomorrow, we're going to do these for practice. Okay, so that's it. If you guys have any questions, let me know. If you don't have any questions, I'll see you tomorrow. And don't forget, you do have labs this week on campus.